Welcome to Walkabout the Galaxy, the #1 astronomy podcast in the world. Where the science is,
via what metric doesn't matter.
Where
Number
the
one.
Science is universal, the opinions are personal, and the introduction is absolutely, literally 100% accurate.
Sure.
Mm-hmm.
Uh-huh.
We are Strange Charm topping down the Astroquarks, also known as Josh Caldwell.
Addie Dove.
Jim Cooney.
And Audrey Martin.
Coming to you from the Walkabout studio at the University of Central Florida. Subscribe to us on Facebook, Instagram, and YouTube. Downquark Audrey Martin, to my right, is absolutely crushing it on Instagram.
Oh,
so
yeah.
be sure to follow us there for special behind-the-scenes treats.
That's going to make the cut.
That was your crushing?
Yeah.
Crushing it on Instagram.
Give us a you rock crushing in the
Oh,
lab.
yeah. Mortar and pestle.
Mortar and pestle.
You can also contact us at wtg@ucf.edu with questions, suggestions, and compliments. Our stumper today is completely random, or should I say a stumper that took me 0.7 seconds to think of.
Wow, cool. Great.
Many of our stumpers have been, you got to spend some amount of time in some sort of situation. That's what this one is.
Sure.
If you could spend a day, you must spend a day
Where am I going to find this day to spend?
as an animated character in an animated universe.
Oh.
Which animated universe do you choose to spend your day in
Oh.
as an animated?
Does it have any
Character.
repercussions on your life?
No, you got in and out.
Rick and Morty.
Rick and Morty.
That's a good one.
Why?
Universal shenanigans.
Yeah.
Okay.
Yeah. Can I choose?
That's Addie's all about the shenanigans.
Yep.
Shenanigans. I've never seen that one.
that, like
I'm
any-
aware of it.
Like Rick
Me-
and Morty
me
at all?
neither,
Yeah.
Jim.
Wow.
Yeah. I just
What?
like. I know that it's like a popular thing amongst the kids these days, but I just
Also,
can't.
It's not a
Also,
kids these
Not
days.
kids,
I think
but
it's
like-
No.
I don't mean kids. I mean like I don't know,
anybody
Not
younger
you.
than
younger than me. Yeah.
Okay, boomer.
Yeah. Exactly.
Jim's not a boomer.
I know.
I'm a boomer.
He's acting like one right now.
Yeah.
Yeah.
By
What is-
calling anyone
what
in
is-
the generation below him.
Yeah.
What is Rick and Morty?
It is a cartoon.
About Rick and Morty? And who are they?
They're cartoon characters.
Rick
Are
is
they humans?
like a
They are
super genius
sort of
scientist,
humans.
and Morty is his grandson.
In most universes, they're humans.
Okay.
Yeah.
Occasionally, there's hijinks and they're not
I
human.
guess on it, no. In
don't know
most
that they're
universes,
humans.
they're not humans.
I guess that's
in the
true.
universe that is on
They
the
move
cartoon,
between-
they are most of the time humans.
Okay. All right.
Okay,
Jim, what about you? What? what's
It's
your-
easy. The Smurfs.
Oh,
Really?
I love that.
They're
not see that
so
coming.
happy.
Love that.
It's just they're.
They're
Which
The only
Smurf would
problem
you be?
is the ratio of dudes to girls is not good.
I mean, maybe it's better
It's
than you
just a
see
day,
on the show.
Jim.
And
What
it's
are you
just
planning?
A day.
Well,
That's a good point.
You're
That's a good
like
point.
expecting your animated cartoon sojourn is going to be some
I only need
kind
a day,
of
Joe.
like sex vacation or something.
no, I'm going with the Smurfs. It's fun.
Okay, Smurfs.
Smurfs.
Audrey.
I think it would be cool to be in Avatar: Last Airbender, and then I could be an
That's a good
Airbender.
one. Yeah, which
Okay.
you would be an airbender?
Oh yeah, for sure.
Okay.
That's
yeah.
another one I've heard of.
I'm aware of, but have never seen.
Have you seen the new live
I
action
know
one?
what the imagery looks like, but I don't know what it is.
Yes.
I've heard the movie's real good.
Well, in keeping with the theme of things I haven't heard of, I'm going to choose also one that I have heard I've heard of but don't know what it is. I'm going to do one of those also.
Oh,
Pinky and the Brain. I
Ah.
think is something.
Okay.
I don't know what it
Are you going
is.
to take over the world today?
I don't know anything about
Just
it.
say
It's very
like
funny.
we do every day.
Like I do every day.
yeah.
Yeah.
Can I
there we
ask
go.
why you would pick a universe you don't know anything about?
Yeah.
Because the consequences are non-existent.
Sure. Okay.
I don't know, because I thought I would introduce Pinky and the Brain to the conversation. That's why.
I love it. I'll try to do that some more.
Does any of you know what Pinky and the Brain
Yeah.
is?
Yeah, it's about two laboratory mice.
Okay.
They want to take over the world. Or one of them does.
One of them does.
Okay.
It's funny.
All right.
It's a good show.
Well, maybe I'll have a
what about Ren and
hilarious
Stimpy?
time.
That's some
Ren and
classic.
Stimpy. Yeah. That Ren and Stimpy is really good.
Beavis and Butthead?
No, absolutely not.
They've been making a comeback.
They have. That one I do know what it looks like. Today we'll talk about primordial black holes and much more, but first, this episode of Walkabout the Galaxy is brought to you by Project Orion. Take your next interplanetary journey with Project Orion. Detonating a nuclear bomb every second, Project Orion will get you to top speed quickly with the added benefit of dumping radioactive material off the planet and safely into outer space. With Project Orion, journey with your crew of 8 on a round trip to Mars in only 3 months. promising the solar system at high speed since 1946. It's time for you to take flight with Project Orion. Project Orion not responsible for mistimed nuclear explosions, blast shield failures, or shock absorber tuning mismatched to bomb yield. Project Orion, built Ford tough.
Chevy.
Yeah.
Awesome.
Is that a real thing?
Dude. Project Orion is absolutely a real thing.
What do you mean? Like a funded thing? What are you talking about?
It was funded in the 50s and 60s.
Oh.
And it was abandoned with a partial, some sort of space-based test ban treaty or something like that, and decided to go the chemical route. But you can take nuclear bombs and you drop them out the back. Notionally, this was the mode of transportation that was going to be used in the ship in Deep Impact. I can't actually, it's even possible that I am the one who pitched that idea to them.
Oh.
But they kind of didn't really sell it that way visually in the movie. You shoot a nuclear bomb out the rear.
Sure.
And it blows up.
Yes.
Very close.
For Taco Bell. Yeah.
Behind, you have a giant sort of pusher plate, and you do have to have some carefully designed shock absorber systems.
Yeah, I was going to say the
be the right
acceleration for that
distance?
seems like it would be,
Crucial.
jumpy and a lot. Like you are accelerating in quick jumps.
Yeah, so
Would that kill people?
like it is 1 second intervals for the explosions.
Oh, that's fast.
Yeah, and so and the acceleration, the kick from the bomb isn't truly instantaneous. It has some finite duration, and so I haven't looked into all of the details, but I'm assuming that 1 second is based on the physics of the of the momentum transfer from the bomb to the pusher plate. And you have a shock absorber, so that's also spreading it out over some interval of time as well. And I think something I've seen like 2 different shock absorbers with 2 different time constants in there, so that you can handle issues with what if this bomb was a little bit more powerful than you planned on it being, or a little bit less powerful. But what's amazing, one of the amazing things about this idea to me was that it was dreamt up and proposed by a physicist already in 1946, 1 year after the first nuclear bombs were detonated. Somebody was like, could use that to send a rocket someplace.
Hey, well, that's better than blowing people up.
Yeah, it is. Yeah. And so they came up with concept missions for it, including a round trip to Mars with a crew of 8 that would take 125 days.
All right.
So probably no time at Mars.
Yeah, I was like, how long are you spending on Mars in this scenario?
Like nothing, I think. I don't know.
Yeah.
They used a version of that in the 3-body problem.
I wondered if this was some reference to some
watched.
show.
Yeah, which was odd, I thought, the way that they did that.
Yeah.
Have you been watching the 3-body problem?
I did watch the show.
You watched the whole one?
I watched the whole show.
We started watching The Acolyte last night, which is the new Star Wars installment.
Right. Yes.
We didn't watch
with Carrie-Ann Moss.
the other. Yeah, I was like, oh, that's the first episode. I was like, oh, she got that from The Matrix. Some move she was doing. That was pretty funny.
Yeah.
And Eric was like, oh, that's who that is.
Yeah.
I'm much better at identifying actors than he is.
Yeah.
She's
really
badass.
I'm really good at it.
Yeah. It's like a family thing.
Space newsy.
Do you ever play those games where you have to identify the actors? There was a DVD you could buy for a while that was a game,
really?
didn't you? I feel like you would have had that.
I mean, there's the we had a DVD movie game, but it wasn't.
Oh, it was for movies.
It was all sorts of different things. Okay. I mean, it wasn't just like who's the actor. It was like what's the movie or what's the line
something
or
like
all
that.
those different sorts
Anyway.
of things. Yeah. Famously, my brother, who is a movie, TV and movie assistant director and director,
he is quite famous.
Played that. We played that game in the family, and
did he do really poorly?
No, he won, and he came in second because after he won, he started over from the beginning, and then he won again.
Oh, nice.
That is amazing.
So that was pretty funny.
One thing I know about him is that he likes steaks.
Well, there you go. Space news. In the Voyager news, there's some happy news and sad news. The sad news is that Ed Stone, the longtime project scientist for Voyager, and he was the project scientist back when I was a grad student.
Ooh.
And, he was like the Voyager
like
project
10 years
scientist.
ago.
I'm like, that's so amazing. He passed away recently, but he was a big figure in planetary science exploration from the golden era.
And he had been project scientist until like 2 years ago or something, I think.
For a remarkably long time.
Yeah.
And I believe Linda Spilker is now the project scientist.
I think that's correct.
For
We talked
Voyager,
about
yeah.
that recently. I think
Yes.
that was who it is.
But I think you have the Happy Voyager
Happy
1
news
update.
is just a little bit follow-up to what we previously discussed, which was that like Voyager 1 had been sort of down for a little while. There had been issues with chatting with it because it's so far away and it's got its wires. It got some bits flipped. And but it seems to be actually taking it's like transmitting data and doing science again from all 4 of its instruments.
Yes.
That are still functioning and useful out
turned
there.
on. Yeah, right.
That's
yeah.
nuts.
So crazy.
It is.
So
Yeah.
amazing.
Way to go. Another good use for radioactive materials.
Really gives some credence to V'ger.
Yeah.
Right,
Yeah.
Yes.
What's V'ger?
Star Trek
Oh, Audrey. Once again. Voyager 6.
Yeah.
Yeah,
In
which
the-
is not
in
a
the
real
movie.
spacecraft, but in the
Right.
movie,
Yet.
that's true. But
I think for Audrey, Star Trek, the first Star Trek movie is going to be a tough sell.
yeah,
It is slow.
Yeah, I'm not selling it.
Okay.
I've seen the recent ones,
those are very different.
but I also don't really remember them
Yeah.
too much.
There, I believe, is something in the observatory.
We have a bunch of observatory installments, I
Yeah.
think, today.
Half Space News, half Observatory is some, I guess, astronomers were looking at the different components of Arakoth, the Kuiper Belt object that the New Horizons spacecraft flew by. And based on the kind of organic material that's on the surface and an expected amount of like radiation and what those materials would turn into with radiation, apparently there's some glucose that would be made.
Yummy.
And glucose is sugar. And that, with a couple of other organics, would make Arakoth taste like sweet soap.
Sweet
soap.
What does
Yeah.
that mean?
What
I
does
mean,
that mean?
Cilantro, sugary cilantro?
Sugary cilantro, there you go.
It's like when you mix like lemon in with your sugar to make it like lemon sugar, you can mix cilantro in with your sugar to make it
gross.
cilantro sugar. And then just throw it in the trash.
Or then keep going and make like a really good mojito with
I was
cilantro.
gonna say, or maybe a
and
mojito or
mint.
margarita would be really
But to be
good.
clear,
so good.
I would do it if they said you can
Yeah.
taste Arakoth.
That's true.
I
Yeah.
would totally
Oh,
do
yeah.
it. Yeah.
You would taste it.
Yeah.
Maybe
That's like a very
How about you,
geologist
Abby?
thing of you.
Yeah.
Geologists.
You would taste it even
I
though
would
you hate
look- I would
cilantro.
look-
I hate
I would lick
cilantro
that.
less than Jim does.
Oh, really?
Yes.
Oh, I hate it, but
I will eat
How do
things.
you like soap? Do you like
Again, I'm not
better than
Same as
cilantro. It's better than cilantro. Oh yeah, it's
Okay.
better than, I'd eat like 10 bars of ivory before I ate 1
10.
leaf of cilantro.
Well, ivory is a sort of creamy soap. This is a sugary.
Right, so it's even better. It's
This
gonna be
is
pretty
a
sugary.
sugar-
Oh, it's like a sugar scrub.
This is a
Oh, there you
sugary
go. There you
yeah,
go.
yeah, the nice exfoliating one.
Oh.
I'd eat that.
Yeah.
Well, I wouldn't taste Arakoth, but I would use it to wash up.
I think we
I
have a
would use it
new-
to scrub.
I think we have a new thing for the Walkabout store.
Soap.
Some
An Arakoth sugar scrub.
Arakoth.
Yeah.
There we go. All right. Yes.
Come in a little snowman bottle.
The Walkabout store is definitely like
Expanding its product
it's
line.
going nuts.
Yeah, we're definitely moving into the personal care items.
Yeah. You know.
Right.
Okay.
After you take off your Walkabout shirt, clean up with some Arakoth sugar scrubs.
Maybe they can sponsor our next episode.
Okay.
Sugar scrubs.
Arakoth sugar
yeah.
scrubs. Right. Yeah.
Okay, there's another observatory thing. Oh, we
That would really put a strain on Josh.
Ooh.
I really
got
wanted
his-
to do the
He's got his
Oh,
gears,
no.
his gears a
creaky
little
dome.
stuck. That's just like our
Wow.
dome. It
Going.
always gets stuck because it runs out
Yeah.
of oil, or the tires get flat. Ours has like physical blown up tires,
inflatable
so the
tires.
tires get flat.
Yes. If you've ever been in an observatory and they move the dome around, you would understand.
Yeah.
You're lucky stars
It's a giant creaky,
that it works.
Yeah.
squeaky operation.
Yeah.
It's like me
Anyway.
getting out of bed in the morning.
What was the update?
So, nearby star system, Beta Pictoris.
Oh yeah, Beta Pic.
Beta Pic.
Beta Pic.
That's a
famous.
Yeah. It's younger than our solar system.
Yep.
Yes.
It's still got a protoplanetary disk.
Yes, exactly. And so the cool thing that just happened, I guess. So back
You know what they call that? They call it a pic disk.
Pic disk.
What you did there.
Took a second.
Hey,
I knew there was
astronomers,
something
show
there.
us
I'm
your
like,
pic discs.
I don't know how well it'll work, but I got to try it before the moment is gone.
Hashtag pic disc.
Hey, that's a beta pic
There's
disc.
a hashtag.
Oh.
Yeah.
It's less- anyway, what about Beta Pic? Does it taste
whale.
like cilantro?
I don't think so. I don't know though. I'm not sure. But it was observed with Spitzer, the Spitzer Space Telescope, in 2004, 2005.
I was going to say
and
that
there
thing's
were-
not still going.
No. Yeah, it was a while ago. And they noticed that there's this really strong evidence for emission. So a lot of like silicate dust, basically. And then they looked at it again with JWST this year, or last year, I guess, and saw that a lot of the dust, most of the dust, has dissipated. And the idea is that what they were seeing with Spitzer is a recent collision in some type of like asteroid belty,
Yeah.
terrestrial planety type of region, but that dust has now dissipated.
Yeah.
Ooh, what a great thing to talk about in Origins in the spring.
Yeah.
Ooh.
This article.
Nice.
Yeah. So that's pretty cool.
One of the cool things about Webb and Spitzer is that they look in the heat signature and they can see like the dust populations really like it changes the slope of the curve that you're looking at compared to like if there are those dust populations there, they give you this really interesting spectral slope that's different than if they're not there. But then you
And
can also see
because we always are
Webb,
talking
you can probably
about
see specific features.
Yeah, exactly. Yeah, you can see all the features. Well, you can see the features in Spitzer as well. It was apparently very bright.
Well, but Spitzer's just like 3 points.
Mm-mm.
Yep.
Nope. I promise you it's not.
Agree to disagree, I guess.
I did my
Ooh,
dissertation on it.
I said there was some. It's
Fighting
down.
words.
It's happening.
All right.
I literally did my dissertation.
It's
How many
definitely
wavelengths did it have?
4.
No, it's hyperspectral.
It's
Okay.
It's hyperspectral.
what the heck
In
does that mean?
That's
as
like-
opposed to multi-band, like as opposed to discrete bands, it's got I don't know.
I guess all the data I've ever seen from the exoplanet people is not.
it
It's
must have been a
just discrete
different
bands.
It must have been a different mode or something.
Yeah.
Yeah.
But like, yeah, you can see
Well,
it.
Anyway, the big picture thing here I think is cool
Spectrum.
because we're always talking about how like when our solar system formed, in the early days it was just like things crashing into other things all the time, and it's not so much common anymore.
Right.
But here we're seeing a young solar system where that's actually we caught it happening. Big things hitting other big things.
Yeah. There's been a bunch of disks, protoplanetary disks we've talked about in the past that have like transient events, and we've been like, is it a Dyson sphere? Probably not.
No.
Is it aliens? Probably
Right.
not. Is it a megastructure? Probably not. It's probably things running into each other and making more crap.
Right. Right.
Which is also really cool.
Which is cool. Not as cool as a Dyson sphere, to be clear, but quite cool.
There's
yes.
one other spacey news kind of thing, which was that we've been having all these solar events recently. We've talked about how it's created cool aurora here on Earth.
Yeah.
But there's little rovers on the surface of Mars who have been capturing images of like increased activity due to these solar storms at Mars.
Increased
What-
activity
what-
meaning
what?
atmospheric activity?
Yeah, so you can see like more radiation exposure. You can see like the solar storms. So like Mars has a much thinner atmosphere and it doesn't have a magnetic field. So you don't get the same like auroral features that we see here, and so you don't see like aurora at lower latitudes like we do. But the spacecraft on the surface used like Mars Curiosity rover and could detect more charged particles at the surface, which is like really interesting, but also like not great if we were to send humans to live on Mars, because like you're much more exposed to radiation generally, and then during things like this, you have a lot more radiation. So like all the camera images are a lot snowier than they usually are. So that's usually like more radiation hitting the detector and messing it up.
There's like a GIF GIF. I don't know where we all fall on that line.
I fall in the GIF.
GIF. Okay, so there's a GIF in the article, and it's a series of images, and I'm guessing some of them are during the solar storm and some of them aren't. The only real difference I see is a little kind of halo-y looking thing. Is that the solar storm, or am I looking at the wrong thing?
I don't know which one you're looking at.
Like this. And there's
well, it's a snowy image, so there's a lot of
there's a lot of radiation
background
probably.
noise.
Oh, so this is just
it's a nighttime image, so it's partly that. It's partly those streaks could potentially be things.
Cool. Okay, cool.
Yeah.
Yeah. Yeah, if you go outside the Earth, we're
very lucky.
Very fortunate to have a protective magnetosphere and a protective atmosphere.
Probably has to do with why we are the way we are.
Probably.
So we're just going to have to live underground, right?
It's not
if we go to Mars.
Yeah.
Yeah.
Or with
Props.
significant...
Of a huge dome of very protective stuff.
You know where else they live underground?
Where?
Montreal.
What?
There's
They
a big
do have, like, a whole
What?
underground
There's a whole giant underground
city,
mall
basically,
there.
yeah.
Kind
What?
of downtown Montreal.
When I was
I'm
up
very
at the
excited. It's
University
only
of
2 hours
Minnesota-
from my new home.
Oh, that's nice. I've heard it's really nice.
Yeah.
When I was up at the University of Minnesota, they have tunnels between a lot of their buildings. It's called the the Gopher Way.
Yeah.
Gopher?
Yeah, and it
That's
was
so
fun.
cute.
We got to go in them
Gophers.
because it was raining, not because of snow.
Our trivia today is inspired by our sponsor, which, as you'll recall, was a particular form of rocket propulsion involving spitting nuclear bombs out the back of your rocket and having them detonate every second, and the impulse, the momentum would be transferred from the expanding photons and charged particles from the bomb to your vehicle. So we're talking about rocket engine efficiency, one of Jim's favorite topics. Rocket engines.
All right, I'm gonna win this one.
So
out of
one of the
spite.
ways that's measured is in a quantity called specific impulse.
Oh, yeah.
So specific
things
frequently in
confuse me.
scientific usage, the term specific means divided by, normalized by, or divided by something like mass.
It's not just really detailed.
Right. In normal everyday usage, it means yes.
Darn scientists and engineers with their
It
specific
means
words for
something very
things.
different. And impulse means your change in momentum. So this sort of means it's the change in momentum that engine gives you per unit of fuel. That's what the specific part means. And you can measure that unit of fuel either in mass or in weight, which are different things. If you measure it in weight here on the surface of the Earth, Audrey's now passed out from boredom.
Trying really
Check
hard.
Instagram to see an amusing reel of Josh literally boring Audrey to death.
It's not good. When one of the hosts is being bored by this, it does not bode well
Great
for the listeners.
sign. Quality stuff where 2 out of 4 co-hosts find the show tolerable.
Parody that. Parody that.
Nice.
So the units are in seconds. If you take change in momentum divided by the weight of the fuel, you have it in units of seconds. So I'm going to give you a couple of examples of specific impulse of some engines. Your trivia is, what is the highest specific impulse of an engine that's ever been made in seconds, and what kind of engine was it? Okay?
Okay.
So here's a couple of points to normalize, because without any point of reference, it's not something you go around in your back pocket, like specific impulse of something.
Totally.
An airplane turbofan jet engine has a specific impulse of 3,000 seconds.
Okay.
Okay.
The space shuttle solid rocket booster had a specific impulse of 250 seconds.
Okay.
Okay. So less
Time.
efficient conversion of the mass of the stuff to change in momentum of the vehicle.
Okay.
What is the highest specific impulse of an engine in seconds? What kind of engine was it? We'll come back to that after Jim takes us with a very powerful engine out beyond the Milky Way.
Yeah. Last episode, we talked about an alternative to dark matter. Because we always have this problem. No, dark matter is super sexy and awesome. Don't you fall asleep.
Wow.
But here is more updates on, not an alternate to dark matter, but a candidate for dark matter.
Oh.
Are they auditioning?
Yeah.
Is it axions?
It's not axions. It's primordial black holes.
Ah. All right.
Okay.
I can get on that.
Yeah,
Program.
I think I'm on board with this program too. I mean, we have struggling so hard to try and find what these things are, and we so often default to there's some kind of particle that we haven't yet found, which is reasonable because the particle physicists keep on telling us there's all these hypothetical particles, and maybe one of them could be our answer. But not all answers are particles. Some of them are more potentially interesting things like primordial black holes. There's the very early universe.
Primordial means
from the very, very early universe, right? From that have been around for a long time. So these are not black holes that form as a result.
Very early, long time. I mean, sometimes that means 1 billion years ago. Sometimes it means a tenth of a second after the Big Bang.
Right. So here, that's what we're talking about. We're talking about
a second after the Big Bang.
Well, much less than that, like 10 to the minus 15 seconds after the Big Bang, kind of thing.
10 to the minus 15 seconds after the Big Bang.
This kind of thing.
We made some black holes.
We made some black holes. Potentially.
Super primordial.
Those are very primordial.
Wow.
Yeah.
How big are they?
So they range in mass from something like the size of... So I think about the mass of an asteroid-ish. Okay. Of course, a black hole the mass of an asteroid. We love asteroids.
It's like a little
So I would taste an asteroid. Would I taste a primordial black hole?
What's it going to taste like?
So.
It seems dangerous.
It does seem
How
dangerous.
many licks does it take to the center of the primordial
So the event horizon, well, this is an interesting thing because you
One.
could swallow it.
Yeah.
You sure could.
Oh, yeah.
Because the event horizon...
How big is that? Yeah. Can you guess how big that black hole would be?
What's the mass of an asteroid? There's all kinds of asteroids.
Right. So we'll say it's, 10 to the 13 kilograms or something like that.
I was bluffing because it's not like that answer is actually going to help me come up with a reasonable guess. But
right. So these are like the size of an atom.
Okay, I was going to say a centimeter, so I would only have been off by a factor of several orders of magnitude.
It's pretty small. So these are very tiny things, and we think that very likely if these were created, they were created in a wide variety, from that all the way up to things that are 100 solar masses.
Okay,
which is nice because we find a bunch. Remember, we've talked, in the podcast when we talked about LIGO and all these things. We find these colliding 30 solar mass black holes.
Tens of solar masses.
Where did they come from? Well, maybe they got built up from stellar mass black holes, or maybe they're primordial.
Because our sort of normal way of making one of the normal ways of making a black hole is a star somewhat bigger than the sun goes through its life and it expands, yada yada yada. Eventually, it blows up, and the core is so massive and there's nothing left to support it, so it becomes a black hole.
Right.
That's just a tiny fraction of the original mass of the star.
Mm-hmm.
And the biggest stars are only sort of in that kind of 100 solar mass range. So the 100 solar mass star produces a black hole that's like, 5 or 10 solar masses?
Right.
So something like that.
Right. But we're seeing all evidence of all these 20, 30, 40 solar mass black holes. So where do they come from?
Maybe some of them came from 10 to the minus 15 seconds after the Big Bang.
Maybe they did.
How does this work, Jim? There's some cosmologists sitting around. They go, how about if there were some black holes, say, I don't know.
No.
10 to minus 15 seconds after the Big Bang.
It's a perfectly reasonable. It's a perfectly reasonable because that
could be dark matter.
How do you make black holes? I mean, you make black holes when you smush matter into a really small space, right?
Matter was already in a really small space.
Right. Yeah. In the early universe, you have all this matter in a really small space. You have all this matter in a really small space. If there's enough ripples in that, if there's enough places where the density is a little higher and other places where the density is a little lower, the higher density places, even though we're only talking about really small masses, can collapse into black holes, right? And that's what happens when you have supernovas is you take a big amount of mass, you smash it into a really small space, and once it gets into a space smaller than the event horizon, then it collapses. Yeah. Well, that same thing can happen on much smaller scales in the early universe if conditions are right. And of course, we don't know exactly what the conditions were in the really, really early universe. We have lots of versions of that. And in some versions of that, there's going to be lots of blobs collapsing down into black holes.
I mean, the challenge is, of course, the universe as a whole did not become a black hole.
No.
So while it's very, very dense,
Phew. Yeah,
there's some internal energy that's keeping that stuff from collapsing.
Right.
So those little tiny areas that are becoming asteroid-sized or stellar-sized black holes have to be in a sort of very cold spot in that very, very hot.
Cold.
Dynamically.
Yeah.
So how does that, is that feasible? The whole thing is so crazy dense and so crazy hot.
Right.
Don't you need a little piece of it that's unbelievably colder than that in order for it to collapse down?
No. I mean, many of these models create...
Shoot. My clever setup in question was just casually dismissed.
Yeah, but crazy.
It all depends on how smooth things are. If
If
things are pretty smooth, then it's not going to happen. But if things are not as smooth, or if the density variations are big enough, then you're going to have regions which collapse. And if regions have collapsed, then they could still be around. Oh, and here's a cool thing. On the very small end of that,
Jim's going to do his dance.
I'm excited. I know, I'm excited. On the very small, because you know how one of the things we always say that
Instagram soon.
One of the things that we always say about black holes is what? They only have...
They're black.
Gas. How many characteristics... How many characteristics do they have, potentially?
12.
Which are?
Charge, mass, and spin.
Right. They can only have 3 possible, right? All other information is lost. Some of these primary black holes could have a 4th thing.
Piece of information.
Yeah, which is color charge.
Oh, is this like a
color
quantum
charge? That's
chromodynamics thing?
Yes, because these things, in the time that these things are produced, the universe is made up not of atoms, not of protons and neutrons, but of a soup of quarks.
I love
and
soup.
gluons.
Yeah.
And these things have another kind of charge. It's like electric charge, but it's a different, it's a different version of that. They have color charge, and potentially then, if you're making black holes out of that, then they could have a net color charge. These black holes.
Do we know how to detect color charge?
So big ones won't have this. It's not like I see a thing it has a color charge, but there are testable predictions made by if those things exist, if those color charged primordial black holes exist, then we may see a specific kind of ripple in the early universe as far as gravitational waves. So we may be able to test this hypothesis in the next couple decades.
Okay. So, but we wouldn't be able. We would be able to see their signature from the early universe, but we couldn't.
No, the ones
the
that
other searches for those particle versions of dark matter or actually detect one of those particles.
Right. We may be able to detect some of these primordial black holes, not the little ones that have the color charge, because they were so small that really tiny black holes evaporate very quickly, according to
Stephen
Hawking. And they would all have evaporated by now. But
a long
on the larger end of the spectrum, they will still be around. And we may be able to detect them more directly by looking at small scale, micro lensing of background things.
Oh, it's your favorite.
It is one of my favorite things.
Yeah. So we've looked for that kind of stuff, for lensing of, you look at the whole sky and look for lensing of things. We haven't seen it, but if they're small enough, you won't have seen it yet, but we may have seen it soon.
Well,
I have a new Astroquark song.
A new Astroquark song. Mm-hmm. How does it go?
Spoonful of sugar, except it's a spoonful of Arakoth, and these are a few of my favorite things.
Okay.
It's inspired by this episode.
There we go. All right. Okay. That's the next one. We still have to get the last one out.
Yep.
That's been in the works for since I was born.
Yeah.
Probably since April.
I have one more question about the primordial black holes. It's where has this idea been for the last 50 years?
Yeah, Jim.
Yeah.
It's been around. It's been around for a few decades. We're starting to take it more seriously because it has some implications for how early you can make structure. If these things exist, you can make structure a little bit earlier, and we're seeing that with James Webb. So it's getting a little more traction these days than it had.
Picking up or dusting off the old.
Yeah, we're dusting out, and the fact that we haven't found anything else in those big searches for the particles is where people are starting to think maybe this is a real thing.
How do the?
I'm kind of rooting for it. I have to say.
I like it. I also like it.
Better than
I'm with
the idea that it doesn't exist, that dark matter doesn't exist.
I do like it better than that idea.
Yeah. And
I also like it
topological circles.
I like it better than the idea that it's WIMPs or something like that.
Yeah.
Cool.
I like it. I like it.
Fun.
All right. So, specific impulse. Specifically, remember your 2 points of reference that I gave you. Yeah. Obviously, the number is going to be higher than these numbers.
No, Audrey was asleep. She doesn't remember those numbers.
Thank you for your honesty.
You're welcome.
While you were passed out, I informed the other hosts and our listeners that the specific impulse of a turbofan jet engine on an airplane
I'm going to be on one of those later.
is 3,000 seconds, and the specific impulse of the solid rocket boosters on the space shuttle is 250 seconds.
Could you say the first one again?
3,000.
3,000.
That surprises me.
Passed out while it took me the time to say that one sentence. This is a real ego boost here. Well, doing great today. I'm doing great today.
I started
Somehow,
thinking about, you got to drive to the airport. And then I lost the sentence.
so 3,000 seconds for one. You have a rocket engine value of 250 seconds.
But those aren't like bounding values. Those are just
absolutely
references.
not. Those are references. You're going to guess the bounding value on the upper end.
Yeah.
Mm-hmm.
I mean, I'm not going to guess it, but I'm going to try.
You're going to
We're
attempt
gonna
to
try.
guess. You will make a guess at that bounding value on the upper end.
Okay, what
Doesn't matter. I'm going to win this out of spite. I already
You're
said
doing
go.
that now. That's what's happening. Yep.
I'm going to be really disappointed in myself because I did a
This
thing
is rocket
several years
stuff.
ago where I knew these numbers. I knew some things that were relevant for this.
I can tell you, if it makes you feeling better,
It won't.
I would have bombed this question.
I'm
And
going to say
that's not an allusion to our sponsor.
1.5 times 10 to the 5.
150,000.
Yeah.
Okay.
You want to say it that way?
That's
I do want to
nice.
say it that way.
That's nice.
I'm going for $1 million.
You're going for $1 million. Okay.
1 million seconds.
I was gonna go. I'm gonna go less. I'm gonna go 30,000
30,000.
seconds.
Rocket expert Jim Cooney gets it closest. 21,400 seconds.
Nice.
Wow.
What kind of rocket engine is that?
Yeah, rocket
I'm gonna
expert
say
Jim Cooney.
I'm gonna go. I'm gonna be a little crazy and say it was a rail gun.
Oh, interesting.
I don't think that's a
Okay.
rocket.
I know, but it's a propulsion mechanism.
It is a propulsion mechanism, and it would have some specific impulse associated with it, which is not 21,400
Bummer.
seconds.
Bummer.
No, it is a...
Do the rest of us get to guess?
Sure.
That's fine. We don't.
It doesn't matter.
It didn't seem like you were going to.
Space shuttle main engine.
No.
Okay.
But that's okay.
Space
Thanks.
shuttle other engine.
No, I
That
told
was
you
the-
that
the
one.
other engine was
while
the
you were
tiny
dozing
number.
off earlier. It's an electrostatic ion thruster.
that was my second guess. I was gonna guess that.
Were you?
I was. That was
That-
gonna be my
that's-
other guess.
that's-
Just because that's the other kind of engine that I could
That's
think
right.
of.
But you didn't say it,
And
so
that's
didn't, so it
why
doesn't count.
they're a thing.
Yeah.
Right, is because they have a very high specific impulse. They
Yeah.
don't...
There's this balance between specific impulse and
and total thrust.
Right.
Yeah.
Yeah.
Because little ion engines have a really big specific impulse, but
But
it's,
there's not a
really
lot of
slow
flow through.
acceleration.
Right, yeah.
So they take a really long time, but once they're going, you're like, here we go.
Yeah. Because you can't
Yeah.
have enough, enough of them to
And
say,
there's hybrid engines where they're trying to work on ways to sort of come in between both, because typically those are the ion engines, and chemical engines have the other.
yeah. A liquid oxygen, liquid hydrogen engine, which is what the space shuttle main engine, what you guessed, Audrey, would be about
blue?
450 seconds. Yeah. So that's a sort of typical chemical rocket engine is in the sort of many hundreds. Your ion are in the thousands. And so this was a high-end electrostatic ion thruster. There's something called a photonic rocket. And the ideal photonic rocket would have a specific impulse of 30 million.
Wow, Audrey was so close.
Yeah.
That's the one she was thinking.
I was thinking about that.
You were totally thinking
Yeah.
about that. Yeah.
That's what I was thinking of.
Or you were thinking about, gee, Addie's got to get to the airport.
Can we wrap this up?
Yeah. While it may have felt like waiting for this episode to end, that is in fact exactly what it was.
Hope you had a good nap.
Yeah. It was just another episode of Walkabout the Galaxy.
Give us 5 stars and we'll give you the universe.
Be sure to follow us on Facebook and Instagram to get all our updates.
Subscribe to our YouTube channel and catch up on old episodes wherever you get your podcasts.
Our theme music was composed by Richard Jurisic. Production assistance is provided by Logan Basinger.
Thanks to our listeners in Wellington, New Zealand, and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
I'm Jim Cooney.
And I'm Audrey Martin.
We're the Astroquarks signing off until the next episode of Walkabout the Galaxy.
What sound would a photonic engine make?
what sound would a photonic engine
I was
make?
I was trying to come up with a tweet tweet pew pew version.
Pew pew sound.
But it's not a laser.
Tweet tweet.